Hi, everyone. My name is Banghua. I'm co-founder of Nexus Flow and incoming assistant professor at University of Washington. So today, I'd like to share with you at Nexus Flow how we build enterprise-grade GenAI software agents using our own customized open language models. So here's one example for GenAI agents. Imagine a case where you have multiple softwares and tools to use together. One example would be the human can and with the instruction like, please go to the concert hall in San Francisco I visited last time and pick up my son along the way. And in the meantime, you do have tools for navigation to get location and get last visited places. So in this case, we hope the agent to interact with the human in a chat interface, saying like, sure, I will navigate and pick up your son, and then also give you some suggestion on the driving speed, etc. But down behind the chat interface, we also hope the model or the AI agents to actually use existing softwares to call the functions to actually execute the task accordingly. So in this case, we hope to first get contact with son, get location, and then get last visited places in San Francisco, and then call the navigate function to do the full navigation. So this is definitely very complex instruction following and tool use capabilities. And we hope to accomplish that in a safe and helpful way. So one simple question is, would simply prompting GPT-4 be enough for these GenAI agents? So we have some case study from our own enterprise customers' voice, where people found that the demo with GPT-4 is really insufficient in accuracy, where the success rate is lower than the production desired, especially for the complex use cases. And also, GPT-4 tends to hallucinate with some non-existent software tools. And in production, we really want minimal hallucination. On the other hand, we also hope to have very low latency, while GPT-4's latency is really not quite acceptable, especially for complex software manipulation tasks. So what's our solution? Before diving deep into that, we did observe some interesting trade-off between two GenAI agents' reasoning capabilities. One is extractive reasoning, which requires a reliable synthesis of intentions. So one example is navigate to San Francisco and pick up my son, where we just hope the model to follow the instructions directly and call the right function. But on the other hand, we also have some abstractive reasoning, where hallucination is not a bug, but a feature. So one example of this would be write me a poem about the moon. So during our development models, we noticed that, especially for small models, it's better to decompose those two capabilities. So for extractive reasoning, we're open sourcing one model called Nexus Flow V213B, which is a model dedicated for function calling that is surpassing GPT-4 in complex tool use cases with minimal hallucination. And on the other hand, for abstractive reasoning, we're open sourcing Starling 7B, which is so far the best Mistral 7B-based chat model in the most recognized human evaluation leaderboard chatbot arena, and it's also surpassing larger models like Mistral 8x7B. So we use Starling 7B to interact with the customer, and behind the scene, we're using Nexus Flow 13B to actually call the right functions. So let's dive deep into Raven first. So we are focusing on multiple cases of tool API. So one example would be single tool API, where the software is only required to call one function to accomplish user queries. And in some cases, we might also need parallel tool APIs, where the user's request must be accomplished with at least two calls. And there will also be nested tool APIs, where we need to first call one function and use that function's output to feed into the other function. So we carefully do the human creation of benchmarks for the zero-shot tool use cases for both single, parallel, and even nested tool APIs. And in our own benchmark, we observe 7% higher accuracy, especially for parallel and nested tool APIs than GPT-4, with a 100x smaller model size. So we start from code Llama 13B, which is a prior coding model released by Meta, and we do the post-training and tuning for tool use reliability. So as a result, we greatly improved extractive reasoning capability for reliable tool use, so that our river model is surpassing GPT-4 with much smaller size. There are also third-party validation for the superiority of our model, where it has shown by the Roth bench paper that our model is only one that attains zero-tool hallucination on the third-party benchmarks, where GPT-4 tends to hallucinate with some non-existent tools. So one example of this would be when I supply the model with two tools like Yahoo search and Bing search, and user asks, what's the zip code for Palo Alto? The agent might hallucinate a Google search and call the wrong function without using the existing functions from the tool list. And we're also comparing our model's success rate with GPT Super 5 and Turbo, where we found that there's a 71% task level win rate over GPT-4 as much smaller model size. So for starting, we're also trying to do human preference alignment at SOTA data efficiency to improve the safety and helpfulness and try to customize for your own model. So we're building new Abstractive pipeline for strong chat model. And at the time of release, our starting 7B model is ranking 13th on chatbot arena. And it's also beating models like Llama 2 70B, Gemini Pro 1.1, and also Mixtral 8x7B. Actually, both Starling and Raven have been released for more than 6 months. And during this time period, there have been much more stronger base models being released, like Llama 3 and Gamma 27B. So what's next for our model development? We have been working very hard to combine both capability of Starling and Raven on a much stronger base model. As a result, we're excited to share that we'll be soon releasing another open model that is much stronger in both chat and function calling. So since it's only a 10-minute talk, I won't be cover all the details here, but happy to check more offline about what we have been doing and also about what we have achieved in Nexus Flow. Thanks for listening.